minus 5 equals to the 7th.
Wait, is the 8x, is it like?
It's the square root, it's not the square root, 7 in the little corner, there you go. 8x minus 5 equals 7, the root 9x plus 5.
9x plus 5?
Yes.
Really?
Yeah.
Okay, this is not a quadratic in form problem. This is a radical equation.
Yeah.
Well, this is a special kind, okay? This is the kind where you actually do have both of them isolated. This guy's over here by himself, this guy's over here by himself. And so how do you get rid of a 7th root?
Multiply it by the 7th power.
Yeah, no, but raise it to the 7th power, right? And if I raise both sides to the 7th power, those cancel, and you get that equals that, and you solve that.
Okay.
Yeah. I didn't realize it was going to give you a 7th root.
Some of these were...
Well, because when I pick them, these numbers are we say, algorithmically generated. And when I picked it, it probably didn't look like a 7. It looked like probably a cube root. And I didn't realize that they might change the 3 to a 7. But that's okay. It still works out.
Thank you.
Okay, that's not the one I want to do.
I'm sorry, do you want to do quadratic form?
I do want to do quadratic in form.
Okay, parentheses, x minus 1 to 2/3 plus x minus 1 to 1/3 minus 6 equals 0.
Okay. Does that look like a fun problem for y'all? It's kind of a mixture of the two that we did do last class. So, yeah.
That's quadratic form, though.
This is quadratic in form. Okay. And I'm telling you that the trick is to look for one exponent being twice as much of it as the other one. The other trick to recognizing that it's quadratic in form, if it has really ugly exponents, if it doesn't look like anything else we talked about, then it's very likely also quadratic in form. Okay? So, do we all agree that, yes, this exponent is twice as much as that one?
Yes.
Okay? We're going to work this problem, but what if we tweaked it? What if we changed this to x minus 2? Is that quadratic in form?
Yeah. It's not, I thought it was to the power.
It is, but that's because I'm assuming something here. It turns out, though, if your bases aren't the same, even if one exponent is twice as much as the other one, if your bases aren't the same, then it's not quadratic in form. And by changing this minus 1 to a minus 2, I've now made this a pretty much unworkable problem. So let's change it back to a 1, shall we? Okay.
So that's another thing you have to, if it's not...
I'm not going to throw you that curveball. I will make sure that you have the same bases if I want it to be quadratic in form. Okay. Same thing would happen if I called that x plus 1 instead of x minus 1. If one was x minus 1, x was, those are different bases, and it's a tricky problem to solve. Okay? But because they're both x minus 1s, and this exponent is twice as much as this exponent, then what should you be?
X minus 1
Yep.
to 1/3.
The 1/3, yeah, the smaller exponent. So since that's what we're defining u to be, then this x minus 1 to the 2/3 power is equivalent to what? U, this is my u squared, plus, that is what we define u to be exactly, right? So plus a u minus a 6 equals 0. And forgive me if I'm repeating myself, but I'm not 100% sure I said this. These guys factor, right? They don't have to, they wouldn't have to, but on all these problems they are going to factor. The problem's clearly enough as it is. If you wanted to use the quadratic formula to solve it, you could, but let's go ahead and factor since it's quick. First terms would be u and u. My signs would have to be 1 plus 1 minus.
Plus 3 minus.
Plus 3 minus 2. Okay, from which I get one solution in terms of u would be negative 3, but the other one is u equals 2. But that is not my final answer. Why not? Yeah, this is u, I need x. So once I get it down to here, how do I get back to x? Well, I replace it with what I defined u to be, right? If u is x minus 1 to the 1/3, then this is x minus 1 to the 1/3 power equals negative 3. And this is x minus 1 to the 1/3 equals 2. Yeah, I'll just leave it alone. Okay? So when I raise it to the 1/3 power, in either case, I'm really taking the cube root of that, right? So what cancels a cube root? Raising both sides to the 3rd power, cubing it. So I cube that side, I cube that side. And if I just work with this equation for now, I'm getting x minus 1 by itself equals negative 3 to the 3rd power is negative 27. So if x minus 1 equals negative 27, add the 1 over. And one solution is x equals negative 26.
And we do that for all the problems. Like once we get u, we take x on one side, and then once you get for u, and then just...
It's all for x. Yep. So ditto over here. This is still a cube root. Cube both sides. So x minus 1 is going to equal 8. So the other solution I get is x equals 9.